absolute value, we need a formula. We need a formula. What formula did I give you? Do you remember? Talking about absolute value, everybody? Is A absolute value equal to what? Come on, Winterberg. Equal to A if A is positive or equal to 0. Ah. Somebody didn't log out.
And then negative A is less than 0?
If A less than 0, correct. Alright, this formula is very important because later on we often have an expression with a variable in there. We need to know how to write it without the absolute value sign. For example, if I give you 2x minus 1 absolute value, what would this be? This would be 2x minus 1 if x bigger than or equal to what? Everybody, can you tell me?
0.
Not 0 now. 1/2 is 1. This is bigger than 0, right? Or equal to 0. And then it would be 1 minus 2x or negative 2x minus 1, which is the same thing, if x what? Less than 1/2. Alright, we often need to deal with this. So I want to, along with this formula, I'll also give you this. This should be the absolute value of A. Of course, then you can further use this formula to get it. Correct? Need to be careful with this. The reason for this, we only use the square root sign to represent the positive square root. For example, square root of negative 2 squared, it would be 2. Some of you might say, oh, I give you positive negative 2. There is a confusion there. When we use this symbol, that represents positive 2. That's it. Alright? How do you represent negative 2 then? That should be represented as this. That is negative 2. Alright? You cannot have one expression equal to 2 answers. I know some of you in the quiz problem, you actually give me a positive negative 3 since you realize something there, but should be. You cannot have one expression give me 2 answers. You can't do that. Right? Okay. Everybody, that's what we did. And then we also reviewed some algebraic formula. Those formula I didn't give you a complete review, but you need to check it out if you need it. And the formulas, most of the formulas is in the front cover of your book. So if you really forgot something, you should check it out. Don't just go with your feelings and, oh, I feel a squared plus a plus b quantity squared is a squared plus b squared. That would be deadly wrong. Alright? If you think about it, you know it's wrong. Right? So you need to be willing to check it out. You cannot just go with your feeling, oh, I feel it that way. Well, sorry, your feeling is wrong. That is wrong. Okay? So you need to be willing to check it out. I'm not afraid you forget something, but I'm afraid you don't think, just go without even check. Alright? The formula, I'm not going to mention those. Alright? Let's continue here. The third part, actually, I already wrote it down. I want to review a little bit about functions. And the test 0 also tell me I need to review this, especially about domains. What is a function? Function usually we denote it by f. Basically, you are giving me an x. I have one y corresponding to this x. So we denote y equal to f of x. So what are functions? Functions is a rule. The rule tells you what y should correspond to the x. Like y equal to x squared, what does that mean? That means you give me an x, I will square it, I get y. Right? Y equal to x cubed. Then the rule said, okay, you should cube your x. That's the y corresponding to the x. So that's what function is. function has a domain. Domain of a function is really all the x such that f of x is defined. Now, it's defined. There are two things you need to consider. First, the formula mathematically got to make sense. So there are two things to find the domain. There are two things you have to pay attention. The first thing is the formula you use to calculate y. The formula needs to make sense. Now, what do I mean by this? What do I mean by this? For example, if your function is f(x) equal to 1 over x, is there any x so that this formula doesn't make sense? Yeah.
0.
0. You can't divide by 0, period, right? So you need to know, so x cannot be 0. So in this case, what is the domain? Sorry. What is the domain of this function? Equal to all x. X do not equal to 0. Does this make sense, everybody? Of course, another thing you need to be careful is, let's say yesterday, actually on the quiz 0, I gave you this function, f(x) equal to 1 over square root of x squared minus 1, right? What is the domain? Actually, this is one of the problems with everybody did very bad. Forgive me for saying that. All right? So how do we consider this? This formula needs to make sense. The first thing, there is the denominator. Denominator cannot be what? 0. Okay? That's the first condition you need to think. The second condition you need to think about is there is the square root.
Can be.
You cannot take the square root
Negative.
of a what?
Negative.
Negative number. Very good. All right? So we need to consider that. If consider these two things, what we come up with a condition is x squared minus 1 must be what? Greater than what? 0. And it cannot be equal to 0. Even equal to 0, square root still makes sense. But because it's in the denominator, we really need this. So that means x squared bigger than 0 and root 1, right? Yeah. You guys should error out immediately. All right? X squared minus 1 bigger than 0. That means x squared got to be bigger than 1, right? That means you take the square root, everybody. Square root of x squared, what is that equal to? Now, you guys forgot our formula? Absolute value of x should be bigger than 1. Correct? Now, what does absolute value x bigger than 1 mean to you? Either to the right of 1, think about the real number line, or to the left of what? Negative 1. So that means x less than negative 1 or x bigger than 1. That's what the condition of x. If you want to write this in the interval notation, you can write it in the set notation x. That's the domain. In the x less than negative 1, x bigger than what? Or x bigger than 1. Okay? Close the braces. And then you could write it in interval notation. That's the same as negative infinity to what? Negative 1 union. This cup means union. 1 to what? Infinity. When we write in interval notation, we always put the smaller number on the left side. All right, never write this as infinity to 1. Some of you did that. All right? Okay, so that's the domain. Now, there is another thing. Not only you cannot take the square root of a negative number, can you take the fourth root of a negative number? Can you take the sixth root of a negative number? Yeah, so you get the idea. But there are more than this. What happens when you have log x, for example? X cannot be what?
Negative.
Cannot be negative. Log is only defined for positive numbers. Yesterday, I gave you this problem, 3x minus 1. What is the domain? The domain, you really need 3x minus 1 bigger than 1. Because that's the log. You are taking log of this quantity. So this quantity got to be bigger than
0.
0. That means 3x bigger than 1, x bigger than 1/3. Write it in interval notation, that's this. Does this make sense, everybody? That's how you find the domain. You just have to look at it. That's the first criteria I said. The formula needs to make sense. The second, actually, I'm not going to elaborate much more than just telling you. The second criteria is if your function comes from the real world. Real world. That means you have a word problem, you derive a function from that. Okay? The variable need to make sense. I mean, I use this word because I don't want to write a paragraph for you. What do I mean by need to make sense? If you think about y equal to s squared, s is the side length of a square. I really mean a square. Okay? This function makes sense for any s, the formula. But if this represents the area of a square with one side being s, then s got to be what? Positive. Or equal to 0 if you consider the limiting case. You just have one dot, that's a square. It's silly called a square, but sometimes it's more convenient mathematically. We do that. So that's what I mean. Your function comes from real world. The variable got to make sense in the real world. You cannot have a negative side length. Right? That's what I mean. Okay? So does this make sense, everybody? Then the next thing I want to say in mathematics, we can define certain functions. Let me count what you learned in your pre-calculus. You learned a straight line, that's a linear function. Correct? To generalize that, you learn the parabola, that's a what? Quadratic function. Then you learn other more general polynomials. What are polynomials? X to certain power multiplied by constant bunch of terms added together. Correct? There is a degree of the polynomial, like quadratic degree 2. Linear, the graph is a straight line. Talking about straight line, there is a very important formula for the equation of a straight line. What do you think I'm referring to? Y equal to mx plus b, what is that called? Slope intercept formula. Actually, this is a special case of the point-slope formula. If you are given a point, you are given the slope. Can you write down the equation?
Y minus y1 equals m times parentheses x minus x1.
Exactly. Thank you. Everybody hear that? Right? That's an important formula. We often use this. All right? Of course, you said the slope-intercept formula is just a special case because the point is nothing but 0, b. It's the point. Okay? And then you extend from there after you learn the polynomials. So what did you learn? Tree? We are not there yet. We learn the fractions of polynomials. What are those functions called? Fractions of polynomials. What do you call fractions of integers? Yesterday we reviewed this.
Inverses?
Fractions of integers we call rational numbers. Fractions of polynomials we will call rational function. I'm sure you heard this name before. Rational function? No? go back, find your highest grade.